Okay, now let's just run this code and let's see if I have any errors. So if I play this, oops, right, I think we forgot something. Losses.mst. Okay, let's play this again and let's see. All right, so here, oops, Frank Brain, I forgot to add dot compile. Oops, put it here. Frank Brain, then we compile a model. All right, so let's play this one and see. All right, so that's good. There's no errors. So basically what we had in here is we compiled the model. We determined now, okay, what kind of learner is baby Frankenstein. Okay, so we use now our MSE or our mean squared error. There we go. Sorry. Okay, so we use our mean squared error, but if you want, you could use now any type of loss functions here. Okay, so the code is given to you as well here. And then next, what we did is we determined the kind of learner, what type of learner is Frankenstein. Right now, he's an Adam quote unquote type of learner. Okay, so you could just read through this one on what if you want sorry you could just read through here if you want to see or what kind of optimizer do you want for your baby Frankenstein. What kind of learner is he? So it depends on you on how you want to model the brain of Frankenstein. So you could just read all through of this one. Now that we have modeled now the brain of Frankenstein, what we want to do here next is we fit the model. Okay, so I'll type in the code first before I explain it to you. The Frank brain, okay, dot fit and then TF meaning TensorFlow, expand dims. So this is a reserved syntax, expand dims, and then X string, okay, access is equal to -1, and then comma Y train, okay, Y train, and epochs is equal to 100. Now, I'm going to explain this one, but if you want, you can do something like this, okay, in TensorFlow. So, something like this one. Can you explain this line per line for me? Okay, and let's see. Okay, just press enter and let's see if ChatGPT is good. Okay, but I'll explain this one while ChatGPT is decoding some answers. So here, this code here, we're trying to fit the model. What do we need here? We expand the dimension. Now, if you remember, we have our X train and Y data, and then we want now a dimension to predict the the X and Y tests data. All right. So that is the dimension. Now here we have axis is equal to -1. So here, if you would see here, okay, if the axis is 0, okay, the new dimension will be at the beginning of the data, meaning this one will be, okay, at the beginning of the data, meaning if the axis is 0, it would be here, all right, the dimension to predict the X and Y data. The column will be here. Now, if the axis is equal to 1, then, okay, the column will be here. Let me just expand this one. And so on. Another column there, and then another column, another dimension there. So that is if the axis is 1. But if if the axis is, oh, sorry, the, uh-huh, axis is 1, the new dimension should be at the beginning of the data and so on. Meaning this one would be here, okay, at the beginning of the data, all right? It would be the prefix. But if the axis is -1, then it's a new dimension at the end of the data, meaning here at the end of the data. If the axis is the negative 2, then the columns or the dimensions would be at the end of the data, and so on. Something like that. Okay? And data and so on. That's the reason why we're just using axis is equal to -1. Alright? Then of course, we want to train from the X train data and then Y train. Y train is not defined. If we go back to our code, Y is capital. So it's case sensitive, and then, okay, and then that we just type in capital Y. The epochs is equal to 100. This number could change. But what does this mean? Okay, what does the epoch mean? Meaning, given our data here, we want Frankenstein to look at this data, okay, for 100 times. Okay, that is what we want our Frankenstein to do. Look at it, look at this data for 100 times, analyze it for 100 times. So if you want, you could change this, for example, to 100, 200, and so on. So let's check ChatGPT. Oh, there we go. All right. So if you would see epochs is equal to 100, this parameter specifies the number of times the model will iterate through the entire training data set. Okay. Here, the model will be trained for 100 epochs. Okay. So that's it, and I'll see you in the next lesson. If we could see that, if we will see if the brain of Frankenstein, the thing that we modeled here, okay, the thing that we coded here is good enough and able for him in order for him to predict our test data. Okay, so I'll see you in the next lesson just to see if we created a good brain model. Okay, so I'll see you later.